One. Guys, what is going on? Golly, we hit 1,000 subscribers today. I had a blockchain full stack interview today. Went amazing. Met the team over there, David and those guys. You guys are fantastic. I really hope that opportunity comes through, because that's just everything what I want to do with my career. Blockchain full stack. It's everything. So I gotta sneeze. Oh, that's criminal. The sneeze went away. That is criminal. That is absolutely criminal. Okay, guys. So back to the Python backend roadmap. We're still boot.dev. We're grinding out some Python. We're getting competent in it. Things are feeling good. Okay. Oh, it's back. The sneeze is back. Oh, that is just messed up. If it does that the whole series, guys, I'm sorry. Or the whole episode, I'm sorry. Oh, that is just messed up. Okay, so in this chapter, we're going to try to practice in applying the skills and concepts we learned while building the fantasy quest. Fun. We got some challenges in front of us. Okay, so write a function called numberSum that adds up all the numbers from 1 to n. For example, if we put in 5 and n, so we do 1 plus 2 plus 3 plus 4 plus 5. So it's not just return 5. It's loop through n and return the sum of all those things is what I understand. So what I think we could do is store a variable in just basic memory. Here's our total so far. We're going to return that total. So we'll say total equals 0. Guys, I've been doing the Solidity stuff and deploying smart contracts on this Apulia test network and building this Twitter blockchain clone. It's so fun. I'm loving it. So if you're into blockchain, make sure to check out the Solidity series. It's getting pretty wild over there. But okay, so what I want to do is say for I in n, right? Or we want the range 0 to n, and this should give us all of our all of our i's. So we should have 0, 1, 2, 3, 4. Boom, perfect. And what we can do is say total plus equals, guys, sorry, I'm also out of breath and whatnot. I just went on a run. So I live on this ginormous hill, and it's great. You know, I can go out there, get some sun and get some running, you know? Boom. So actual, it's 10. It's expecting 10. So what are we missing here? We have inputs 5. Actual's 10. So that's not correct. So 0 to n. Is it n plus 1? Is that what we want? Let's see. Boom. There it is. Okay. So I think 0 to n would go 0, 1, 2, 3. It's not including 5. So if we passed in 5, it would go 0 to 5. So I think it's just indexing 0, 1, 2, 3, 4. So I think what we could do is either do 2 solutions here, or 2 solves to that bug. So I think do range 1 to n, or do n plus 1. We'll do n plus 1. It looks like that's working. Sweet. Guys, great job on that. We crushed it. Okay, so minimum number in Python. Assignment, write a function called findMen that finds the smallest number in a list. Okay, so what we want to do is index through them, set the new men. So the men here, the original men is going to be negative infinite. We're going to have similar logic, I think. We're going to loop through this nums array. So we're going to say for num of nums. If, is it for num in nums? Is that what it is? Okay, boom, sweet. So if num is less than the men, the new men is going to be the num. So men now gets reassigned to num. Yeah, I think that's it. And then we just return num, or return men. Let's check. Sweet. So again, this isn't equals, guys. It's reassigning. So remember, men, first we instantiate it. We say men is equal to negative infinite. So it's like less than 0, right? So negative 9999 infinite nines, right? So first we're starting this variable of minimum. So we could say the current men value, lowest men, and then all we're doing is just going through that array. If the array is 1, 2, 3, 4, 54, and negative 1, basically what the array is going to do, let's put a negative 2 here, and then maybe even negative 5. We won't go through all of them, but for num is just each one of those. All it's going to do is just say is num less than the current men. If it is, so right now 1 is greater than. Well, how does this actually work? How would that work if negative infinite is the current min? Wouldn't it always? We'll just pretend that something's working there. But so let's pretend this is 0, right? So current, we obviously can't do 0 because there might be an array with greater than 0. So the current, that's why that works, is because the negative infinite's not a defined integer, I'm sure, is why it might work. Okay, but so the current min is 0. So basically what it's saying is 1 less than 0. If that's true, reassign the current men to 0. So now the current men would be 0, but 1 is not less than 0, so it's not going to do that. Yeah. So basically we're Maybe I made that way more complicated than it needed to be. So we have min, which is the normal value, and then we're just checking in that storage. If any number is less than that, just reassign it to that thing, to that storage thing, and then return that storage thing. Okay, moving on. Guys, I probably made that way more complicated than it needed to be. I'm sorry. Okay, so complete the remove non-ints function that takes a list of this and returns a new list with all the non-integers removed. So it returns only ints. Okay, so how do we do types? Right here, type variable. Okay, so here we go. So we'll say for num and nums. We're just shooting from the hip. Not a lot of strategy planning here. If num is an int, we want to append it to the array. So we'll say clean array or the list. And if that is true, if the type num is an integer, so again, we're looping through that array of like string, integer, booleans, maybe, I don't know what they're throwing at us, but if the type is of integer, we want to push that type into our list, and then else we don't want to do anything. We just want to kind of ignore it, and then we're going to return the clean array. And I think that'll work. Nope. I thought it would 100%. Thought it would. Oh, sorry guys. Add here, which is JavaScript syntax. Let's see, clean array.add. Why is that not working? What do we need to do for adding? Clean array.add, no, list object has no attribute, add. Guys, oh my gosh, I've been spending so much time in Solidity. I forgot how to push to a list in Python. I thought it was add or push, right? Oh, append. Oh my golly. So that's the fun part, learning syntax with all these languages. But sweet, the logic worked great. That's the good thing. When you understand the rough logic of how stuff works, it's like you're learning syntax stuff. Even and that's why I encourage you guys to, like, after you hone in on Python, or if you're honing in on JavaScript, or if you're honing in on any specific language, whether it's C#, C, it's Svelte, Rust. Svelte's not a language, that's a framework. But Rust or something like that. Once you get it, I've noticed this, like learning Solidity is just like, oh, like, okay, so I understand JavaScript and TypeScript really well. So I can just swap in stuff, and then you learn a few other things. Okay, there's viewable functions, there's payable functions, and how do these bytes work? But you're like adding on tiny knowledge, but the core logic of software, or excuse me, of programming, like, doesn't really change. Like, it's still approached the same way in all languages typically. There might be like smaller things. Like Golang has different things that aren't accessible in other languages. That makes it really useful for microservices. But like the core things are still there, of like variables, loops, all that. It's just different syntax, sugar. Okay, and especially with ChatGPT and like where everything's going, like I don't think being polylingual on a programming level is not going to be like too crazy these days, because I guarantee there's going to be, sorry, this is a total tangent by the way, but I guarantee there's going to be a day where people can just, oh, here's my React project, make it in Angular, give it to ChatGPT, and it just like spins up an entire Angular project for you. So it's like all front-end frameworks are going to be agnostic, or same with backend. So like I feel that's probably not too far out, like maybe 5 years away or less, who knows. But okay, so anyway, so complete the factorial function. It should calculate the factorial of a number. A factorial of a number is the product of all positive integers less than or equal to that number. For example, boom, so we want to loop through and then multiply all these things, right? Boom, the 0 factorial is 1. This keeps, okay, so we could do just a default case. So if num equals 1, we'll just return, or excuse me, if num equals 0, we'll just return 1 for the default case, just to handle that. And then everything else we want to do for the loop. So for I in range 0 to num, maybe plus 1 again. Maybe we want to do that. And then, oh, this is what we need to do again. We need to define a total so far. So this will be the total so far. Boom, nice. And all we want to do is say total times equal I, right? Something like that. And then we just return I, or return total, I believe. So let's see. Nope, we're getting some errors. Let's remove this num1 real quick. Let's see what we get. So expecting 0, actual this. Oh, we can't multiply by 0. Okay, so we'll start with 1. Sweet. So that is passing everything, except I feel like they're going to throw a test case with 0. Oh, no, that did work. Okay. All right, well, that works. Awesome. So kind of leapfrogging on that train of thought a little bit earlier of like polylingual stuff and programming as a whole. The important part is, again, honing the fundamentals. Because there's guys who are like really talented at algorithms, for instance, and this is all, if you know the little bits of algorithms, all these huge merge sorts and like in ridiculously huge algorithms where it's like the chess queens algorithm where you have to do like queen's corner on the chessboard. Like there's a ridiculous amount of leak code algorithms, or questions. But and I'm not sitting here in a state of I'm super talented at algorithms, but what I've noticed, the people who are teaching the algorithms, they like hammer in on the fundamentals, because when you can piece the fundamentals together, you could just like break down, oh, you got to do the queen's corner thing and do this, and it's all just tiny problems. It's all a huge problem is just it's an array of tiny problems, basically is what a huge problem is. So it's a group of medium problems, and those medium problems are groups of smaller problems. And if you can relentlessly and fundamentally solve the small things on a really strong brick building way, yeah, you can definitely swing into the larger stuff way easier, rather than doing the opposite. Rather than being like, I'm going to tackle the hardest problems. I'm going to build a rocket without learning how jet propulsion works. Like, I'm going to build a rocket without learning about oxygen. I'm going to build a rocket without learning. Like, you do the opposite. You like learn about oxygen, you learn about jet propulsion, you learn about, and then you build the rocket. Like that's how I don't know. I mean, I don't know. Maybe there's arguments on both sides of that actually, but because I've also had really big projects where sometimes you just throw yourself in the deep end and then you figure it out kind of as you go, which can be really fruitful knowledge. But I think parallel to that thought is like, maybe the reason why I was able to figure out larger problems was because maybe I was competent at smaller ones, maybe. So, but anyway, let's dive in. So area sum, complete the area sum function. It accepts a list of rectangles where each rectangle is a dictionary that has the following structure. So we have our key values here. So we have height and width, and the function. So this is what it should be returning, right? The rectangles basically are going to be, what I understand, this objects with this in it. So we need to loop through each one of these. Here, I'll copy this one, and then we'll change some values. So just so you guys kind of can bird's eye understand as well what's going on. So we have 11, 25 here, maybe 16, maybe like 61. I don't know, really big rectangles. But basically, we're going to be passed a list, and I'll organize it a little bit more structured so it's just easier to digest. So we have a list, which is the array, the square brackets with some curly braces in it, which are objects or dictionaries, which hold these key values in there. So we can keep organizing it if we want this, if we would like. But fundamentally, yeah, we'll just do that. We need to access this data and then multiply it together and then print out. It seems like we need to return. Oh, this is tricky. So we need to calculate the area of each rectangle, then sum up all of them and return the result, then sum them all up. Am I reading that right? So if this was, let's do smaller numbers because I don't want to do that multiplication. So this rectangle should be 30 plus 18. So if I'm understanding the question correctly, it should return 48. Okay, sweet. So this is, I think, the data we're given, right? Let's just print it out just to double check, make sure we're going down the right path before departing. Sweet, it is. Okay, so that's similar thing. We're going to be given this input. And yeah, so the 4 times 5 is 20 plus 18 times 5, which is 50 plus 90. So 20 plus 90, 110. Sweet. Okay, so that is what we're supposed to do. We need to multiply all the rectangles and then sum them all up. So I think what we can do, we could do two things, is put them in a list, do all the math in the list, and then return the list and then reduce the list. Or we could do a similar thing of like, do a total variable and then loop through each one of the rectangles and then just add to the total, return the total. I think would be the easiest. So I'm going to gun for it. Let's do it. Okay, so for rectangle, let me steal this text, rectangle and rectangles. This is where we access it. So we could say rectangle height times width, right? And then we want our total to plus equals that, and we can return the total. And I believe that is our algorithm, folks. Sweet. That was awesome. FizzBuzz. This is a classic. So this is what they said, a commonly overused little toy program that comes up in entry-level interviews. Complete the FizzBuzz. Pressure's on, folks. Complete the FizzBuzz function that loops over all the numbers from start to end, excluding the end value. It prints them. If there's a number with a multiple of 3, we return the word fizz. If it's a multiple of 5, we return buzz. And if it's a multiple of 3 and 5, we print the word FizzBuzz. Okay, so, oh boy. So we have start and end. And if I, right? Oh, we don't need that. So if I is a multiple of 3 equals 0. So that's our modulus, right? We want to return the word fizz. Boom. And basically we want to do that with 5 as well, but instead of return the word fizz, we want to return the word buzz. And then here's the kicker. It needs to be both. Also, we need to check for both. So if it's that and 3, we return the word. Guys, I didn't do a really good job of talking that over. I just started making ands and I recognize. Okay, so this actually isn't going to work, but this is the rough idea. So we need to do one more thing before making this work. But basically, we want to have our number. So if our start and end, so we have a test down there, it says 1 to 100. So one of those numbers will be 15. 15 is also divisible by 3 in a whole, the modulus, this guy, the modulo. He's going to divide and check for any remainders. So you could have, like if we did 14 or 13 or something, 13 would actually be equal to remainder 1. So it wouldn't return fizzbuzz. So because 4 3 is going to 13 to get 12, but then you're left over with 1 left over for the 13. So that's kind of how the modulo, it's division, but it counts, it like includes the remainder. So this would not be the same statement here. Oh, and I have an extra, this would obviously be equal to 5 if we did 15 divided by 3. So modulo works just a little bit different, but okay, so and we actually don't want to check for 3 and 5 first. We actually want to check for this first statement, because if we pass into that point, if we pass in 15 would actually return fizz first, because it does actually, that would actually be correct to do that. And then if 15 also was here, it would also return buzz. And then the program would break out of the loop, it would return. So we actually need to check for things this first. If it's divisible by 5 and 3, or if the modulo's divisible by 5 and 3 with no remainders, first check for that. Then if 15 passes that, great. But let's think of a number. 9 would not pass this, right? 9 is not, it's divisible by 3 or with a clean modulo of 0. Like if the number was 9, right? But it's not by 5. So then it would go to the next one and properly return fizz. So that's a lot of talking. Hopefully that works, right? Let's see. Let's see if we did it right. Starting test, it looks like we're not doing it right. Oh, I need to print. Yikes. Yikes, folks. Yikes. Could have been left in the dust there, you know? Okay, so print. Boom. Great. Let's hope we get it, you know? Hopefully we did it right. We didn't do it right. Ay. Where did we go wrong? So print fizz instead. If the number is a multiple of 3, print fizz. Yeah, that's this seems right. Do we do this? I promise it's the right idea of logic, but okay, let's see. Oh, else print I. Okay, we could also say else print I. Okay, boom. Let's see if that works. Do we need to do elif? Is that super important in Python? Do you have to do an elif? Let's see. Okay, looks like you do. In JavaScript, I gotta be honest, there's so many times where I don't. Or I'll use just ternaries on ternaries. Oh, great. So that's roughly the key part though for getting that is this first bit is like, yeah, that's like key. So for anyone going into the overplayed entry level interview, they want that part specifically. It's like oh, okay, you thought ahead. So take it. If you hear fizzbuzz, remember 3 and 5 first. 3 and 5 first. Okay, so list division. Write a function called divide list. Oh, that takes a list and a number as the input. The function returns a new list that contains all the elements of the original list, except they have been divided by the second input. Interesting. Oh, okay, and it looks like it returns a float of them. Make sure you're appending the raw to float values. Don't round or cast numbers to an integer. Fun. Okay, so looks like we need to have an array, because it looks like it returns an array of these numbers. So I'll say answer array or answer list. That works too, but we need it equal to an empty square bracket, just something to put a little memory in, right? And we say for num in nums, and we could say we want to first num divided by divisor. We actually want to make that a float. And we want to append, sorry guys, it's getting a little wild. We want to append the answer list to that. I think that's it. And then we just want to return the answer list. Boom. Did not spell return correctly. Okay, let's try. Passed. Sweet. Okay. But you can see how my brain was working. I was like, start with the small thing, then like add to it, then like add to it one more time. That's kind of what I'm getting at with like the like algorithms or like problem solving as general. It's like start with the tiny thing, then like you get that done, do the next thing, then do the next thing. I'm not sitting here saying I'm the guru of gurus. I'm just a guru. I mean, I'm just a guru. Okay. Okay, so write a function called join strings that concatenates. Oh no, we pulled out a word, guys. I don't know how to do concats in Python. I forget. Oh, here we go. Because it don't use the join method. Well, that doesn't help. It doesn't help. Okay, so all of it end to end in order and adds the comma between them. Yeah. Can we just have a string and loop through it like tuple and just add to the tuple? Is that possible? No, they got to have a concat function, right? Right. So for string end strings, right. We could say answer string equals this. I guess that is what we're going to do is answer string dot concat string. Let's hope concat works, right? Whose cat is it? It's Colin's cat. Oh boy. String has no attribute concat. I was afraid of this moment. Guys. Not a problem. We'll try the tuple deal. Okay, so we'll say so we need for string in strings. How do we get the index of the length of the strings? Trying to think how would I do this in a loop, right? So can I do range strings length from 0 to this? But that's just going to give us I. We need the actual strings for the strings, right? But I need the index to this associated with the strings as well. So for string in strings, this is you probably could do this not doing it this way. But if I equals strings dot length, we're gonna do a piece of logic here. So the idea is I'm just gonna add it all to the string, and I'm gonna add the string with a comma. But at the end, I won't do that logic. It'll actually be different logic. We'll just add the string at the tail end. There's got to be a okay. Let's see if this works. Strings dot length. Well, what is strings? Is it not an array? Is it not an array? How do we? Oh, wrong syntax, folks. Sorry, wrong syntax. Length of strings. Let's try that. So we failed, but it looks like we're getting somewhere. This list is we're doing two loops. So we don't need to do this. We can do, instead of the answer string, it's going to be strings at I, and I think that'll work. And we want the string at I plus that. Let's try. Nope, spelled strings wrong. Sweet. Okay, we're getting closer. So do you see? I don't know if you guys see the logic I'm trying to do here, but if the I equals the length of strings. So let's say they pass us this one right here. This list is so important. Maybe it's length of strings minus 1 because that's how many? That's 5. So it's going to say 0 to 5 is the index. So I think we were 1 too far. So this is so important. No. Sorry, I'm doing a horrible job of explaining the logic here, but we're so close. I guess what I could do is slice maybe the tail end character. So it's skip, boom. Maybe this. Oh, no, not that. Sweet. Nice. Let's submit it. Let's see if we pass. No freaking way. Okay. That was kind of cool. Okay, so let me explain. I just wanted to make sure we get it done. So first, I'm making the answer string here, just again a place where we could store and stash the variables. And then I'm indexing through just the numbers wise. I'm looping through from 0 to the length of the array being passed in. So we have 0, 1, 2, 3, 4. So the length of the array is actually 5. So from 0 to 5. And then if this is just for the last one, I was trying to, I guess we could actually get rid of that because that logic's not working. So yeah, this cleans it up a whole bunch. So let's focus in on this part, which is just the answer string is being appended the string at I. So if I print string, let's see, if I print string at 0, it'll be the first one. So right here, the input's Dota, strings at 0. Sorry, guys. But it'll return the first thing. So we have this, right? That's the first item being printed. So I is just that index, right? Again, so we're just showing the string now at the second one, or the I part. So the first index is list, the second position in the array. So all I'm doing is just adding that with a comma at the end. So I'm taking strings at I, so it'll be strings at the 0th position, so this, and then strings at the first position, which is list, that is at any of the I positions, the index, right? And then we're adding that comma, and then just here, I'm just deleting the comma at the very tail end is all I'm doing. So sweet. Let's see what they did. I bet there's a concat thing. Oh, sweet. They did do a similar thing. I like our logic better, guys. I got to be honest. I like it better. Just seems clean. Seems simple. It's like, well, here's what we did. We just kept it easy. But either or, tomato. There's 15 ways to cut the cat. I just realized I said cut the cat, but sweet. So no freaking way. That was chapter 13 done. Let's cruise through the Zen of Python. It looks like we have some questions here, and guys, we're done with the first thing. So simple is better than complex. That is so true. We want as simple of a solution as we could possibly make that still fulfills the requirements. It's okay for the special cases to break the rules. No, not really. An implementation that's easy to explain is a good idea. Yeah, probably. Maybe. Yeah, it's going to be always or maybe. An implementation that's easy to explain is, yeah, we'll go with always. It's going to be maybe, of course. Dang it. There should be blank ways to accomplish a task. Many. We'll go with that. But okay, there should be at least one ways. I would disagree. I think there's always many ways to accomplish a task, right? Build something that returns the number 2. Well, I could give you a function that adds 1 plus 1. I can give you a function that adds 0 plus 2. I can give you a function that adds 1.9 plus 0.9. I can give you a function that adds 100 divided by 50 divided by return string 2, convert the number into 2, convert it to an integer. You could do 100 different things to return 2. I don't know. My opinion is there's 100 ways to cut the cat. But okay, which language typically allows for code to be released more quickly? Well, it depends on how competent. We'll go with Python. I'm sure that's what they're trying to push here. The best reason to use Python is because the code runs fast. It compiles fast. I don't know if it runs fast. Okay, so print Python 2 really needs to die already. Fair. So update the syntax for Python 1 versus Python 2. Okay, sweet. We're cruising through, guys. Python 3 is always good and backwards compatible with Python 2. I imagine it is. Looks like it's not. Okay. Thought it would be, to be honest. Thought it would be. Congratulations, guys. We completed the first course. 1,000 subscribers today. Completed the course. Blockchain engineering full stack interview. Fantastic day. Holy crap. What a fantastic day. And guys, thank you so much for, if you made it through all this, get yourself a little celebration for getting through this. You got to celebrate the things that you want to see keep happening, right? So all wins, big wins, all of it. Celebrate the tiny wins. Get yourself a little Chipotle is what I'm going to reward myself with today. But do your thing. Whatever your thing is. If it's I also love cheesecake. I might go get a little cheesecake from HEB. They sell these Oreo cheesecakes that are just perfect. But yeah, celebrate the small wins, because they built the momentum. And if you've stuck with this series and you're hammering out these episodes and building this foundational knowledge with me, yeah, we're obviously going to keep crushing. We're going to keep the momentum. We'll get to everything. We have all the time, guys. We don't need to rush, but it's important to run through your understanding really well. Make sure we're up to par with that understanding. And biggest thing, congrats. Getting through that first course, that's huge. Understanding programming as a whole is like it's a foreign language. You're like understanding how logic works with itself. Like it's weird. It's this weird meta place. So go out and celebrate a little something for yourself. Don't go too crazy. This isn't go party. This is go get yourself a nice something for getting through that course and taking it serious. If you were able to get through this far, it's very likely that you're able to continue this entire program. And boot.dev, this is not a sponsor, but I hope you guys can see the transparency of how wonderful this program is, and I'm looking forward to the next section, which looks like shells and terminals. So it'll be a fun time to run through some terminal stuff, and then we'll get into some inheritance and encapsulation and abstraction. We'll cruise through some more Python, and we'll dive into my land a bit with a little JavaScript on the back end, which will be fun. And then the Golang. Golang is going to be great. SQL is obviously a necessity for backend engineering. Docker, Kubernetes, CI/CD pipelines, all that fun stuff is super, super important. So yeah, we have ourselves a bit of a series, guys. It's going to be a good time, and just stick with it. and append other courses into your life, append other knowledge. So take that Python knowledge now that you've gone this far with, and build something with it. You know, build something tiny, whether it's a FizzBuzz program or something tiny. Build something tiny and just keep those fundamentals core and strong. But again, congratulations to you for getting this far and making it through the whole. I will see you on the next one. Cheers.